Hello everyone, this is Pre-Calc Lesson 66, Formulas for Systems of Equations and Phase Shifts and Period Changes. So what we've done previously is we solved problems with abstract coefficients. Well, now what we're going to do is we're going to use those abstract coefficients to derive a general formula to solve for our variables. So we're going to substitute our numerical coefficients into our formula we got from the abstract coefficients to derive for x and y. So here's an example. We will use abstract coefficients to solve for x. So if I have these two equations, 3x plus 2y is 8 and 4x plus 5y is 3. Okay, I am going to create this new system. Ax plus by is c, dx plus ey is, f. Okay, I'm going to use my abstract coefficients first to solve for x. So as we did before, I'm going to eliminate y. I'm going to multiply this top equation by negative e, the bottom by b, giving me minus aex minus bey equals minus ce. And then I will have dbx plus bey equals fb. I add these together and eliminate y, giving me db minus aex equals fb minus ce. So x is fb minus ce over db minus ae. Okay, now if we relate these two equations, I know that a is 3, b is 2, c is 8, d is 4, e is 5, f is 3. I'm now going to substitute those in here for x. So x, we have f, which is 3, times b, which is 2, minus c, which is 8, e is 5, over d, which is 4, b, which is 2, minus a, which is 3, times e, which is 5. Okay, makes it really, really, really easy to solve this now. So now I just plug in these points into my calculator, and I get x is 34 over 7. Ta-da, done. Okay, let's do the same example, but solve for y. Okay, so again, I know that a is 3, b is 2, c is 8, d is 4, e is 5, f is 3. I'm going to solve for y by eliminating x. So I'm going to multiply this by a minus d, multiply this by an a. So I get minus a dx minus b dy equals minus cd. And a dx plus aey equals fa. My x's cancel, and I get ae minus b dy equals fa minus cd. So y is fa minus cd over ae minus bd. Okay. So I know that f is 3, d is 4, c is 8, d is 4. A is 3, E is 5, B is 2, D is 4. Okay, and this ends up giving me negative 20 over 7. Negative 20 over 7. Okay? So, abstract coefficients, you need to know how to use them. Now, let's get into phase shift and period changes. Okay? We remember that our regular period in sine and cosine is 360 or 2 pi. And we talked about to find c, we do 360 over a period, 2 pi over a period. To remind you, these are our general forms. We're going to now use y equals a plus b sine of c times x minus d, or using it with cosine. Okay. Now a new trick we're going to have is you can factor. If you have y equals the sine of 2 theta minus 90, we don't really see our coefficient c in there, so we can factor out the 2, so y equals sine of 2 times theta minus 45, and that gives us our coefficient c. Okay. So with all of that, let's do some examples. Okay, so this first example, I am going to write both sine and cosine. Okay, so let's do cosine first. So y equals a plus b cosine cx minus d. Okay, so a is my center line, which they've given me here, is 4. B is my amplitude, or the distance from 4 to my top. I've drawn one too many dashes, but my top is 7. So the distance between 4 and 7, my amplitude is 3. Okay, I see that normally cosine should go through the y-axis, but I've moved to the left 90. So I will have x plus 90. And now I need to find c. C is going to be 360 over my period. And I've gone from negative 90 to 450, which is 540. So I do 360 divided by 540, which gives me c is 2/3. So I'll have y equals 4 plus 3 cosine of 2/3 times x plus 90. Okay, now the great thing is sine is going to be exactly the same, 4 plus 3 sine of 2/3. The only thing that changes is my shift. Okay, now we know that sine normally goes through 0, 0, but here we've moved to the left 225, so I'll have x plus 225. Okay, all right, let's do this next example. Write both sine and cosine. This one might be a little more challenging. Let's start with sine. Okay, the reason we start with sine, I think it's easier because this is my y-axis. Sine has no horizontal shift. So I'll have y equals a plus b sine of cx minus d. Okay, a, it's going to be harder to find. Let's find b first. So I look at the distance between negative 7 and 3, 1, 2, 3, 4. I divide that by 2, which gives me my amplitude is 2, which means my center line, I go to my top and I go down 2. So my center line is negative 5. Okay. So then I want to find, I already know that d is 0 for sine. I want to find my c. Well, if I look here, I go all the way up and all the way down, and I've started again, I'm at 120. So I do 360 divided by 120, and it gives me 3. So I will have y equals negative 5 plus 2 sine of 3x. For cosine, it will be very similar. Y equals negative 5 plus 2 cosine of 3. Now I look to see if I have a phase shift for cosine, which I do. Normally cosine goes through the y-axis, but here we've moved to the right 60, so I have x minus 60. Okay? As I've said over and over and over and over, we're going to build on this again and again and again and again. So if you don't understand how to do this now at this level, you please come into student hours and we can figure it out, or spend more time tonight studying.